This is Emission System Test 6, and from the Fuel and Emissions Control Systems textbook, chapters 19 and 20, Fuel Supply Systems. We're going to talk about fuel supply. Incidentally, where are you guys on your no start out there?
We're not getting any readings to the TP sensor.
There's not anything getting to the TP sensor, right? Okay, as you got power at the fuel injectors?
I have to solder the.
Okay, you got to make sure of that, okay. All right, let's go ahead and start here. If it's tripped, which type of safety device will keep the electric fuel pump from operating?
C.
The inertia switch. That is C. Yep, and that's only on some vehicles. Every vehicle doesn't have an inertia switch. I could be out in left field here, but I have never known of any GM vehicle having an inertia switch. But Fords have them, some Nissans have them, some Toyotas have them. Sometimes they'll have inertia switches on the hybrid vehicles tied into the hybrid system too. They'll have more than one inertia switch on some of the hybrid vehicles. Number 2, fuel lines are constructed from what?
C.
A and B.
Oh.
Believe it or not. Either nylon plastic or seamless steel tubing. Some of them have both on the same car. What prevents the fuel pump inside the fuel tank from catching the gasoline on fire? Because after all, the gasoline flows right through the pump, around the brushes and everything else. So what keeps it from catching the gasoline on fire?
D.
It's going to be C. No air is around the motor brushes. There's no oxygen. If there's no oxygen, there's no combustion. They've been doing that on aircraft for a long time before they did it on cars. That was pretty spooky to me when I found out about that. That the fuel was flowing right through that little pump in the bottom. You know, your fuel pump is that little cylindrical fuel pump. The only part of it that's the actual pump is the very bottom of a little wafer down on the bottom of it that's got a little gerotor in it. And it pumps that fuel right through the pump motor to keep it cool. All over the brushes and everything, they're just spinning on gas. A good fuel pump should supply how much fuel per minute?
D.
0.5 to 0.8 gallons. Even when we had fuel pumps that were driven off the camshaft, that had little diaphragms in them, they would want us to check and see how much fuel they would deliver. Spinning the engine over a certain amount of time, they were supposed to produce a certain amount of fuel, move a certain amount of fuel. Technician A says fuel pump modules are spring-loaded so they can be compressed to fit into the opening. Technician B says they're spring-loaded to allow for expansion and contraction of plastic fuel tanks. Who's correct about that? That's actually B, but one of the primary reasons that they put those spring-loaded pumps in there like they do, they push it so it's pushing against the bottom of the tank, and so that if there's any water that gets in the tank, as far as any condensate, moisture condensate, the fuel pump will pick it up and deal with it in smaller amounts. Because if you got just a tiny little bit of water going in there, it can go on through. The fuel filter may catch some of it or whatever, but the point is, years ago, they would have the fuel pump would be on a sort of a stiff, be drawing, it would be on a stiff thing like this. The fuel pump would be here. I'm drawing this as sort of, and the bottom of the tank would be here. And then it would go out the top, and then your fuel lines would go and all that. Let's just say that the fuel pump's here. Well, this would be probably an inch off the bottom of the gas tank. And so when people are driving around with their gas tanks about 2/3 to empty, they would wind up with condensate collecting on the bottom of the tank. And over time, you'd wind up with a bunch of water in here that was sloshing around. And that water occasionally would get a wave that would go through there, and the pump would pick up just nothing but water. So when you're making a turn, and it sloshes over and some of the water picks up, you lose your power and then you come back. So what happened was they started putting the pump on the bottom of the tank. And I don't guess the guy that wrote this textbook knew that, but they put these spring-loaded rods, right, that are going to push the thing down, and they put that thing right against the bottom of the tank, and it's basically drawing, in a lot of cases, through little holes like that. And it acts like a vacuum cleaner, so that if there's any water in there, when there's still just a tiny little bit in there, it draws that water through there, and it deals with it. So you don't have that kind of problem. Now the expansion and contraction of the gas tanks is a factor, but there are steel gas tanks that have these spring-loaded filters in them too, So they're pulling it off the bottom of the tank. Sometimes they'll have a sock out here and all that kind of thing too. But one way or another, that's the primary reason the thing, and there's also a reservoir in here, like that, so that if the fuel's sloshing around You know, you want to find a place where the fuel has sloshed away and the pump has lost its prime for a second. That'll cause you issues too. I've run into that before. One time, and here, let me tell you this story while I'm thinking about it. There was a fuel pump on a Chevrolet Cavalier, I think it was an 88 model. And it was basically, the way it was mounted in the tank, the fuel pump was like this right here, and there's supposed to be a sock on it, right? And the bottom of the tank was pretty close. On that particular one, it was pretty close to the bottom of the tank. Well, on the, what I got the thing for was they said when you stop it stalls, it go dead. And so I noticed whenever, not only when I'd stop would it stall, but it would stall when I was backing up. It didn't stall taking off going forward, but it stalled when you're backing up. All right, and so the problem was, whenever I was doing that, and it only did it when the gas was a little bit low in the tank, like half a tank or whatever for some reason or another. But somebody, when they put a pump in there, this screen had fell off of it. And whenever the weight of the gas was pushing on the thin metal bottom of that tank, it would keep it pushed away from there. But whenever you stopped, the gas would slosh forward and the bottom of the tank would oil can up, and it would do this, and it would stop that up. The way I found it was I put a fuel pressure gauge on it, and I noticed when I would back up, I'd lose fuel pressure. When I'd stop going forward, I'd lose fuel pressure. So when the gas sloshed forward, this would go doom, and it would stop up the pump. But then it would, you know, oil can back down, and it would get gas. But the sock that was supposed to be in there was rolling around in here somewhere because they knocked it off. There's a bunch of reasons why you don't need to let that sock come off of there. If a sock comes off there, it can pull little particles of dirt in there, and if one little particle of dirt goes in there, it'll stop that little pump, and then you got a dead, you know, pump. I don't know how many times I've seen it where the pump wouldn't spin because somebody had done that. You know, and knocked the sock off on the way in, and they said, "Oh, heck with it," and put it on in there anyway. That sock really needs to be on there to keep that stuff from messing the pump up. That was a long story, but I had fun telling it. Okay, so incidentally, number 5 is B. Most fuel filters are designed to remove particles larger than how big?
Okay.
D.
10 to 20 microns. What's a micron? What is a micron? How many microns does it take to make a millimeter?
100.
1,000. If you take a millimeter and break it into 1,000 parts, you got a micron. It's a millionth of a meter. All right. An amperage draw of an electric fuel pump is higher than expected. All of the following are positive causes except A, clogged fuel filter, B, corroded electrical connections at pump motor, C, defective fuel pump, D, restriction in fuel line. That's number 7. Can corroded electrical connections at the pump motor make it draw too much current?
No,
They won't. Less current won't spin as much. There you go. So figure that out. If a fuel pump's being replaced for the 3rd time, you had to put 3 fuel pumps in this doggone car. 3 fuel pumps. Would you consider there a problem there if you had to put 3 fuel pumps in it?
Yeah.
Technician A says the gasoline could be contaminated. Technician B says the wiring to the pump could be corroded. That's basically B. Now, why would corroded wiring cause you to have to replace a fuel pump? Because sometimes the pump wouldn't run and people would assume the pump was bad and they'd put another pump in it. Now, if you got corroded wires and low voltage going to a starter, that low voltage will burn up a starter because it's like it's stalled out all the time and it just heats everything up and destroys it. That doesn't typically happen to a fuel pump because a fuel pump is not, you know, working quite as hard as a starter is. Fuel filter has been accidentally installed backwards. What's the most likely result? It's going to act like it's stopped up, guys. Low power at higher engine speeds and loads. I've never put a fuel filter on backwards, but sometimes it happens. Now, you won't always have that problem, but sometimes you will.
What was number 7?
Number 7 was, this one I was talking about was, corroded electrical connections are not going to make it draw more current. They can keep the pump from working. All right, Technician A says the fuel pump relay is usually controlled by the PCM. Technician B says TBI injector squirts fuel above the throttle plate. Who's right about that? Both of those guys are right. TBI is throttle body injection. Throttle body injection was sort of a bridge between the carburetors and regular fuel injection. And you can actually buy, if you're driving a car like that Cadillac that we work on sometimes, that old red one that the president of college has, if you wanted that thing to run really, really, really smooth and get really, really good gas mileage, there's a $1,000 fuel injection kit you can get on there. You could put throttle body injection on a car that's running with a carburetor. There's some stuff you got to add to it and all that, but anyway, I've done that before and it works real smooth. It's pricey though. Why are some fuel rails rectangular in shape? Why are some fuel rails rectangular in shape?
B.
Believe it or not, it reduces noise. What kind of noise are you concerned about on your fuel rail? Click, 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 click. You know, nobody wants to listen to those dadgum injectors clicking, right? So basically you do that. If you put it reduces noise because of the shape of the rail, enables it to, dampen that somewhat. Which fuel injection system uses the MAP sensor as the primary sensor to determine the base pulse width?
Demand delivery?
Speed density. Speed density. The speed is the primary input for firing the injectors. The density of the air in the intake is the secondary. Because if you got low, remember, if you've got an engine idle and you got high vacuum, low pressure, right? If you're deep into the throttle, you got higher pressure and lower vacuum. So lower vacuum means more of a load, and that's basically the way that works. Okay, let me see here. Let me see. Wait a minute. Okay, why is the vacuum line attached to a fuel pressure regulator on many four-port fuel-injected engines?
C.
Well, they're concerned about an equal pressure drop across the injectors. Now, if you've got vacuum in the intake around the tip of the injector and you got pressure out here, they're concerned that as the vacuum in the intake drops, they want to lower the fuel pressure 10 psi, whenever you got wide open, like 18 to 20 inches of vacuum, 2 inches of vacuum equal to 1 pound of pressure. And they were concerned about that for a long time. But then they found out it wasn't a big deal. Engineers were saying, okay, now, we need to actually modulate this pressure based on how much manifold vacuum we got. We need to lower the pressure accordingly. That's what the fuel pressure regulator's got a vacuum line going to it for. But there's too many of these vehicles now that don't have that. And I've seen people just leave that thing unplugged and drive it, and it doesn't seem to make a whole lot of difference. But one way or another, which sensor has the greatest influence on injector pulse width besides the mass airflow sensor?
TP sensor?
Yeah, there you go, TP sensor, good answer. Technician A says the port fuel injectors operate using 5 volts from the computer. That's totally hogwash. Technician B says sequential fuel injectors use a different wire color on each injector. That guy is correct. Sequential fuel injectors, why do they call them sequential?
They go in a certain order.
Firing order. They follow the firing order. On the Bronco that we got out here, they fire in 2 different banks. You got the front 2 and the back 2 on opposite banks, and the other front 2 and the back 2, and they're going to pop, pop. It's only got 2 pins feeding all the injectors, 58 and 59 on that engine controller. All right, let me see. What type of port fuel injection systems uses a, what type of port fuel injection systems uses a fuel temperature and or fuel pressure sensor? Electronic returnless systems. That's what that engine sitting right over there has got on it. And some, what about the Neon out there? It's a 95 model, and it's got a returnless fuel system on it. The fuel system, the fuel pressure is regulated at the gas tank. Inside the gas tank, all that's coming out of there is the amount of pressure you're supposed to have. You notice the little Toyota engine we got on the stand out here? I'm just delivering a straight 40 pounds of pressure, air driven to the fuel rail on that one because it's got the fuel pressures internally regulated in the tank. It doesn't have a fuel pressure regulator up here on the fuel rail per se. Why are dampeners used on some fuel rails? Occasionally, what you'll have, wait a minute. Yeah, that's it. I'm sorry, that was 117. A damper is something you're going to see that looks kind of like a little diaphragm with a rim around it, and sometimes they'll even have a vacuum line going to it, and the fuel line will go through it on the way to the rail. And the reason that's there is because that fuel pressure, that's another way of handling the noise. The fuel pressure is bouncing on that diaphragm like jumping on a trampoline, and it keeps that vibration from cycling into those lines and making noise under the, floorboard was that for the fuel lines run. Where's the fuel pressure regulator loaded on a vacuum biased port fuel injection system? It's going to be at the outlet of the fuel rail. In other words, the fuel rail, the fuel comes into the fuel rail and it feeds all the injectors evenly, and then on the way back to the tank is where that fuel pressure regulator is. In vacuum, pressure drives the bottom of that thing open, that regulator, and it lets the fuel go to the return. Those will always have a return line going back to the tank. If the return line gets pinched, the pressure will be too high, you'll have fuel trim issues and all that. What type of a device is used in a typical idle air control?
Stepper motor?
C,
Listen to him, stepper motor, he got that right. And Technician A says most fuel injection systems use the PCM to control the pulsing of the injectors. Technician B says most fuel injection systems use the PCM to control the operation of the fuel pump relay. Both of those guys are right on target.
What was 13?
What, 15 or 13?
13.
Oh, 13, let's read that one again. Why is a vacuum line attached to a fuel pressure regulator on many port fuel injected engines? It's to create an equal pressure drop across the injectors. They had the idea that with vacuum in there that it would be delivered more fuel than you needed. And so that concludes emission systems test 6.